My friends of class 9, today in this session we are going to start with the new lesson work and energy. In particularly we will be discussing about the topics work, energy and the scientific concept of these two things. So let us start. There is a difference in the way we use the term work in day-to-day life and the way we use it in science. For example, we are sitting in a room and we are trying to study something. In day to day life, this is a work, okay? However, in science, from science point of view, this is not a work. Then what is work in science? Well, in science, the work is something which is associated with the force applied and the displacement that happens. So, if I apply a force and if there is a displacement, then only we say that work is done. Well, the definition of work is we can define work to be the equal to the product of force and displacement, both literally as well as mathematically. Why literally? Because the product of force and displacement it also means the outcome of the force and displacement when they happen together. And mathematically means what? Product of force and displacement is nothing but force multiplied by displacement. So both literally and mathematically the definition is correct. Okay, so work is what? Work is nothing but the product of force and displacement. So work done is equal to force into displacement. So mathematically we calculate it in this way. Symbolically you can write W is equal to Fs, where F is force and S is displacement. Well, suppose there is this table and if you try to push this onto the right hand side, what will happen? It will try to move towards its right hand side. Then if the F is the force and S is the displacement, then work will be equal to F into S. Thus, work done by the force acting on an object is equal to the magnitude of force multiplied by the distance moved in the direction of the force. Work has only magnitude and no direction. So while calculating work, we no need to consider its direction. Now, unit wise we will see. If F is equal to 1 Newton and S is equal to 1 meter, then work done by the force will be 1 Newton meter. Now, the unit of work which is 1 Newton meter can also be written as joule. In fact, most of the times we use joule as a unit. Thus 1 joule is the amount of work done on an object when a force of 1 Newton displaces it by 1 meter along the line of the action of the force. So if you are applying a force of 1 Newton and if there is a displacement of 1 meter, then you can say that yes, the work done is 1 joule. Let us see a numerical. A force of 7 Newton is acting on an object. The object is displaced through 3 meters in the direction of the force. Then what is the work done in the moving object? Suppose this is the object, okay, you are applying a force of 7 newtons and there is a displacement of 3 meters, okay. Don't see these numbers, okay, because I have changed the number purposely, okay. Well, F is equal to 7 Newton and S is equal to 3 meter. So work done will be F into S, that is 7 into 3. So 7 into 3 is what? 21 Newton meter, or you can say 21 joules. So it's simple, isn't it? You have to simply multiply the two numbers, force and displacement. Let us see one more numerical. This is a little different. There is a potter who lifts a luggage of 12 kg from the ground and puts it on his head, which is 1.2 meters above the ground. Calculate the work done by him on the luggage. Well, a mass is given which is 12 kg, displacement is 1.2 meters. So this is your first step. While solving any numerical, first you have to write down whatever information is given. So work done will be obviously F into S. But here remember that we don't have force. Okay, we have to calculate it. So what is force? Force is nothing but mass times acceleration. So mass is given, right, 12 kg, and acceleration is due to gravity, which is around 10 meters per second square. So here we take 10 meters per second square in place of gravity, acceleration due to gravity, and mass वो तो दिया है, it is given 12 kg. So multiply them with the displacement or the distance. So 12 into 10 into 1.2 will give you 144 kg meter per second square into meter again. So meter per second square, here there is a kg and here there is a meter. So this also you will multiply. Remember that kg meter per second square is nothing but Newton, right? And Newton into meter is nothing but joule. So finally you can write down 144 joules. So work done is 144 joules. So this is your final answer. Now the concept of energy. Living doesn't seem possible without energy, right? We cannot live without energy. We cannot do even the simplest task like reading or hearing something if we don't possess enough energy. You might have observed what you feel when you are hungry, right? When you are hungry, you cannot think of anything, you cannot hear to anything, you cannot do anything, right? Because all our bodily functions are dependent on the energy that we get from the food. So how does an object with energy do work? An object that possesses energy can exert a force on another object. When this happens, energy is transformed from the former to the latter. The second object may move as it receives energy and therefore do some work. Thus, the first object had a capacity to do the work. This implies that any object that possesses energy can do work. So, which objects can do work? Whichever has the energy. And how does work happens? If you have energy, you can apply a force, and if there is a displacement, then you say that he has energy to do the work. The energy possessed by an object is thus measured in terms of capacity of doing work. The unit of energy is same as that of the work, that is joule. Now we will talk about forms of energy. There are different forms of energy. Like there is a mechanical energy, which comprises of kinetic energy and potential energy. Then there is a heat energy, chemical energy, electrical energy, light energy. Likewise, there are many different kinds of energies. Now first we will talk about mechanical energy. And mechanical energy, as I said, it is made up of kinetic energy and potential energy. Let us see kinetic energy. Kinetic energy is the energy possessed by an object due to its motion. So whenever there is a motion, you can say that it possesses kinetic energy. The kinetic energy of an object increases with its speed. For example, if this is the arrangement that I do in my lab, and if I place a certain weight onto this, okay, now if I place more and more weight, its velocity is going to increase, and thus if velocity increases, then you can easily find out how kinetic energy is increasing. Okay, so it's easy. You have to simply use the formula for a kinetic energy, which is half mv square. Now how do we get this half mv square? Students, there is a derivation for this particular formula, half mv square. What we generally do in this case is we use a derivation using a kinematic relation. Okay, so we use kinematic relation to derive this, but we are going to do this in a next session. For a time being, we will see potential energy. What is potential energy? It is the energy possessed by an object by the virtue of its position or configuration. For example, if I am holding an object and if it is at height, say h, okay, and you want to find out its potential energy, well, in this case you can easily find out by using the relation mass times gravity times height. Okay, so m into g into h. So that way you can calculate its potential energy. For example, bow and arrow. When you stretch your arrow onto the bow, there is a potential of it that the arrow will move and move swiftly in particular direction. Okay, so this is a potential energy because you have not yet lived the arrow, you are just holding the arrow, but you know that it has a potential of moving in certain direction, right? So this is what we mean by potential energy. There are numerous other examples, like if you stretch a rubber sheet, now you don't live it, but you know that it has a potential that it will again regain its original shape. Okay, so potential energy is something which is present by the virtue of its position, orientation, or configuration. Well, students, that was all for today. Next time we are going to continue with the lesson. Okay, and yes, if you have any doubt, please feel free to ask. You can put your comments in comment box. So see you during next session. Until then, take care. Bye bye.